Okay, continuing from the first part of PQ. Okay, so this is the detail. Okay, where we start to learn about voltage site mitigations. So there's two types of solutions that we can suggest, such as dynamic voltage restorer (DVR) is a static device where it adding the missing voltage during the voltage sets activities. Basically, this means that this voltage inject like a voltage like UPS. Okay, when the voltage have this abnormality, okay, it bring back to the normal level or acceptable level. Next is ferro-resonant transformer. Okay, in the ferro-resonance transformer, we call it a constant voltage transformer. It's different, okay, than the normal voltage transformer. Is a constant voltage transformer that operates in the saturation regions of BH curve. Okay, so voltage set normally down to 30% of rated voltage can mitigate it using this type of transformer, CVT transformer or ferro-resonant transformer. Next is electrical transients. Okay, transients is a disturbance that involve destructive of high magnitude, meaning it happen at the high magnitude of current and voltage. It can be both. It can reach up to thousand of volts or amps, and it can happen even in low voltage system. However, it's the characteristic of this phenomenon, the transients is very short duration, less than 50 nanoseconds. Maximum can go to up to 50 milliseconds, right? And the source of transients normally due to lightning. You know, lightning is very fast. Switching activities when you close or open our disconnectors due to maintenance, due to breakdown, due to correctional activities, capacitor bank switching when we close where breaker your when such as a fault happen, our breaker is open. Normally, it's a temporary fault. Try to reclose our breaker, so it happen in transients, transformer type changing, or it can be happen due to loose connection in distribution system that happen to produce an arcing. Okay, okay. Whereas my PhD focus on pulsar discharges, where it is small arcing. It not even a arcing. It just it discharges. Okay, it can be due to human error, human activities, animals, weather, or neighboring facilities. So the effect of transients, one of the effect is happen in our electronic equipment. We have to know that our electronic equipment is very sensitive. Our motors, our light, our equipment can be malfunctions. Okay, and can be due to the TVSS installations. Our efficiency of our electronic devices will reduce. So this is what happened due to transients. Even though it's a short durations activity, it happened to affect our small electronic equipment. Other than that, our motors will run at high temperature. Over time, it will fail. Okay, micro jogging, motor vibrations, excessive heat, noises. Okay, degrades our insulation. So this is something that we have to think, because our motor winding, when they have insulation degradations over time, it can be fail. Okay, losses, we have hysteresis losses due to transients, and temperature rise due to transients. Next is light, our fluorescent bulb. Normally there is no more bulb, ballast failure due to transients. Black rings at the tube. Normally you can see our frozen tube, the ends, we have some black rings. So that indicating we have transients issue in our home. Even though if we not origin for our home from our supply, okay, so it happen affect our frozen bulb. Premature filament damage due to especially incandescent light. So normally it's rarely used today. Next, electrical equipment. Transient degrades the contact surface of our breakers and switches. That is something that we want to avoid. Nuisance tripping, suddenly tripping without any faults, without any fault. Okay, transformer efficiency will drop due to hysteresis losses, similar to motors. Right. Next is FACS, flexible AC transmissions, is integrated system that based on power electronic switches, converters to enhance. Okay, we have to know what is FACS. FACS is flexible AC transmission system. Okay, where we have a controllers and converters. The focus of these FACS is to guarantee the system is stable, is secure, is reliable. Okay, so there are three types of connections for our FACS. It can be shunt, it can be series, or it can be combined. So where I label, okay, I label as different color, orange and blue. Orange refer to thyristor based controllers, where the blue is voltage source based controllers. You can explore more for each types of facts. So fact itself is an enhancement performance parameter system, okay, as a RP support that minimum the AP losses, the VP losses, and improvement of damping ratio of power systems. Okay, facts apply for controllers and power system to enhance the performance of the system, especially when we have issue due to load flow, maybe transients, maybe due to the dynamic stability. We have I have shown a different types of fact devices that available. We have SVC, Statecom. This is the most common one. Okay, TCLC, UPFC. Okay, and we can compare their performance as plus. Best is triple plus, better is two plus, and good is only one single plus. Right. So this is the circuits of each types of facts. This is SVC. It's a combination of thyristors control. Okay, we have combinations of inductor and capacitor. We have filter. Okay, we have type changer. Okay, so this is a few types of statcom. Okay, and also we call it facts that happen installed in our power system in order to improve our power quality. Okay, so the transmissible power of the system can be represented as this formula. PE is equal to V1, V2, 1 over X. Okay, X is referred to the statcom sine delta 1 minus delta 2. Okay, so these all the combinations of UPFC. So we have few components. We have SVC, TCRC, SSSC, RPFC, TCPST. So these all are included in UPFC. That is why UPFC bring the best of performance, especially for fax controller. Okay, for advantages of using fax. Okay, we can exploit the current transmission assets without additional equipment, meaning all those some of our system have been installed with these few types of system. Like in Malaysia, it's all controlled by our National Load Dispatch Center, NLDC. They can manipulate all of these components during abnormal activity. Okay, so they can counter back, okay, the system. Next, it enhances the flexibility or reliability of current transmission systems. We know that current transmission system is our backbone. Therefore, we need to maintain at the mean level. Okay, we want to reduce loop flows, and also it has some environmental benefits. Next, harmonics. What is harmonics? Harmonics is a voltage or currents at multiple fundamental frequency. Normally it's third, fourth, fifth, seventh, so on and so forth. So it happens, this is the resultant of each harmonics. It originated, as I mentioned before, due to non-linear loads. Nowadays we have rectifiers, we have discharge lighting, we have saturated magnetic devices. All those devices are contributing in producing harmonics, where it happens, it will alter our original sinusoidal signal. Okay, what is a non-linear loads? Okay, normally we have switch mode power supplies, we have variable speed motors, drive, multipliers. This is something that we use every day, printers, fax machine. But in these situations, harmonics are happen in our system, and the distortion itself is transmitted by this nonlinear load. The effect is the harmonic current will increase the heat losses. Therefore, when we lose our energy to heat, we we reduce our efficiency. Okay. Normally, we call the terms of harmonics, we call it THD, or we call it a total harmonic distortions. To describe the net deviations of nonlinear waveform in our ideal sine waveform. Okay, so THD is the ratio between the RMS value of the harmonics and the fundamental value RMS of the harmonic itself. That is what we call it TD. So effect of harmonics, again, normally it draws a large load current in the neutral wires. So something that we do not want to happen. Okay, it will brings again hazards to its user and even equipment. If you have a higher neutral to ground of more than 2 volts, this is something you have to ponder, meaning the current is very high. Okay, sometimes it happen to communication error. We have hardware damage, cable transformers. So overheating can damage. Overheating is something that we want to avoid. That's why certain power utilities, they do like uh, thermal graphic monitorings. Okay, because harmonics is something that we can see, we cannot see. We have to measure, we have to monitor using flux devices, equipments. But the effect we can monitor: communication error, overheating, generator hunting, clock errors, okay, equipment malfunction, trippings, metering errors. So something that we have to monitor in our system, in our equipment, in order to know if there the activity, the phenomenon of harmonic happens in our system. All right. There are certain techniques that can be used to in, to improve our harmonics, such as we have line reactor, we have isolation transformer, K factor transformer, tune harmonic filter, IGBT base fast switch harmonics, 12 and 18 pulse rectifier, phase shifting improvement also active harmonic filter. So this is the first part. The second part of PQ. Thank you very much. I will record the next class. Assalamualaikum.